Hi, this is Richard here from Stonehenge Aotearoa, and I'm bringing you some stuff on the night sky. Laptop on. Yes, okay, so as I said, from Stonehenge Aotearoa, I always like to thank Dame Broughton from Wairarapa Web Design for supporting this programme. And we're going to be looking at what we've got in the night sky at the moment. I guess the thing you'll notice first of all is if you go out in the evening is that big brilliant star that's right out in the west just after the sun sets. And there's often another stream of other stars behind it. Well, that big bright star is actually the planet Venus. And also called the evening star at the moment because it's in the evening. And the other bright stars you can see in a line in that region, which are, if you'll notice, from night to night slowly changing their position, they're also planets. Mercury was there, it's now gone, but certainly Jupiter and Saturn is also there as well. And Venus is the most brilliant star-like object you can see in the sky. If you know where to look, you can actually see it in broad daylight. All right? But the thing is that when you look at Venus through a telescope, what you notice is that it's got phases just exactly the same as the moon. So we see a crescent. Right now, if you have a look at it, it's got a gibbous shape. And of course, it was these observations of Venus which allowed Galileo to more or less decided that this was the evidence he needed that the sun was at the centre and not the Earth. You see, because the only way you can see phases on a thing is if it's actually orbiting around on another planet. If it's orbiting around the sun, of course, Venus is closer to the sun than the Earth is. And Venus has always been a spectacular object. It's been part of our folklore, but also part of all the science fiction stories and that we have. But unfortunately, when we look at Venus through the telescope, it's rather disappointing because there's very little detail to be seen. In fact, we cannot see the surface of Venus. Its surface is completely shrouded, perpetually shrouded in cloud. Furthermore, because it's shrouded in this cloud, and that the ancient belief by astronomers in the past as the age of the planets was related to their distance from the sun, so they believed that the Venus was younger than the Earth. Furthermore, being shrouded in cloud, they thought that these were steamy clouds, much the same as what we have in, shall we say, on the Earth. And because the Venus was believed to be younger, it was believed that Venus itself was in a primordial state. So it's Earth's twin, it's virtually the same size, right? But it was believed to be a primordial planet. So they believed beneath the clouds there will be these swamps with weird and wonderful plants growing and so on. And even possibly, well, dinosaurs living down there. Maybe they were in the age of the dinosaurs. Now, I want you to notice what's happening here. The view that we get of Venus is that we can't see the surface of it at all. The conclusion reached by some people that there must be dinosaurs living on it. Well, unfortunately, it didn't live up to this wonderful expectation of finding a Jurassic Park next to us. Turns out that when we do look at Venus, and this we can only do with spacecraft, radar, they found that Venus is in fact the nearest thing to hell that you can imagine. Now, this doesn't seem right because Venus is a little bit closer to the sun than the Earth, and as I mentioned earlier, it should be a tropical planet, not a searing mass. And indeed, looking at when we landed spacecraft at the surface of Venus, first of all, which was the Russians, it lasted for a few moments and then stopped working. Then they sent another one, and that worked for a little while and then stopped working. And they thought, well, something's going on here, so they sent an armour-plated spacecraft. And when they got to the surface, they began to discover the temperature on the surface of Venus approaches 600 degrees Celsius on occasions. In other words, the surface can virtually glow red hot. Furthermore, the atmospheric pressure is 90 times that on the surface of the Earth. right? So that's the sort of pressure you'd have if you went to the bottom of the ocean. You'd literally be crushed by the atmospheric pressure. And those beautiful clouds that once upon a time they thought were, rain clouds, it turns out they're clouds of sulfuric acid. So if you landed on Venus, you would have the unpleasant effect of being crushed, burnt and dissolved. But how did such a world evolve in the first place? You see, because the interesting thing is, when we analyse from stuff that's coming back from spacecraft that have landed on the surface of that, it appears that once upon a time, long, long ago, Venus was indeed very much like the Earth. And what has happened over time, it had oceans, possibly even life there. But what happened over time is that the sun is slowly increasing in brightness. Very, very slowly, over millions upon millions of years. So once upon a time, when Venus was a water world like the Earth, our Earth was a frozen planet, virtually. But what happened with time, the sun gradually warmed, the atmosphere and the oceans began to slowly boil away, releasing carbon dioxide into the atmosphere. And that is a greenhouse gas. And what happens then, you have this runaway greenhouse effect whereby the entire planet then turns into an inferno. So, of course, the same fate is awaiting the Earth in the distant future. One day it too will turn into a monstrous world like Venus. But fortunately for us, at this stage, we don't have to worry about it because that's not going to happen for at least 1.5 billion years. Anyway, that's mighty Venus, and I thought afterwards we're having a little piece of music now. I'll put up Listen for those who've got watching this on TV, but I'm afraid I managed to leave my music in the car, so we're going to have an entirely different piece of music. Is that for John? And so here we go, and when we come back we better look at global warming. All right. Okay, folks. Well, obviously that wasn't that wasn't listen. And anyway, we'll get back to our when I can find it. There we are. Getting back onto there. I'm not quite sure what that piece of music was, but we're going to be some interesting pieces of music. I've got Boudicca on later on, so we'll see what that's all about. Anyway, what I thought I'd talk about is global warming in this section, because there seems to be a lot of misinformation going around what it's all about. All right. Now, for those of you who've got TV, what you're looking at is that beautiful picture of actually taken from my garden. You can see Stonehenge just on the right, and then looking across the Wairarapa. All right. And more roughly towards Greytown. So we've got this beautiful piece of land. But what is global warming all about? You know, they talk about a few degrees change, and people think, oh, so what? What if it's a couple of degrees warmer? What difference that's going to make? Well, I'm afraid it makes an enormous amount of difference, because, first of all, it can shift. That can shift the climatic zones. So if we're getting lots of rain right now, in extreme case, for those who've got it on TV, you can see that's what the Wairarapa would look like if the rain stopped coming. In other words, it started to begin to look like Central Australia. So what happens, the rain patterns change. Even if it's not that extreme, what you can grow in a particular area is going to change. All right? So that's the first thing, the shifting in global weather patterns and so on. The other thing is, because the world temperatures are slightly higher, you get a lot more energy. This means there's going to be a lot more storms, violent storms, hurricanes, tornadoes and so on. And if you look carefully around the world, there's a good evidence that we'll begin to see some of these happen at the moment. In Australia, for example, we've got all those fires taking place. But if you look around the world, you see these evidence of these big storms on a much greater scale than we've seen in the past. Now, there are three things which can cause major changes to our environment and our climate. Number one is the sun. I mentioned earlier on when we were talking about Venus that the sun is gradually increasing brightness, but this occurs, something that occurs over billions of years, so we don't need to worry about that part of it. But the sun has got changing solar activity. This doesn't make the sun appear any different or brighter, but what it means is the amount of ultraviolet radiation coming from the sun varies, all right? And also magnetic storms, which can in turn affect the atmosphere and therefore change the amount, the quantities, the relative quantities of different gases in the atmosphere, including CO2, which is the most important one that can affect the climate. So the sun goes through these cycles where it warms and cold, and we know, looking at ancient history, that this has affected the rise and fall of different civilizations. So, for example, if you think of ancient Egypt, I guess same as when we see it on movies and that, they sort of portray Egypt much as it is today. But if you look at the pictures painted on the walls, you discover, and the tombs and so on, you discover that once upon a time, Egypt was a green and pleasant land, and Pharaoh was hunting animals that don't live in the desert anymore. But what happened? One day, due to climate shift, rain stopped coming, and so the whole civilization collapsed, because that civilization was dependent upon the rains and the harvest that it brought. So the sun is a number one. All right, but we know when this is happening, because we can observe the solar activity of the sun these days. The other thing that can cause short-term but very violent changes in climate, of course, is intense volcanic activity. And there have been periods in the past where there has been an enormous amount of volcanic activity. Few millions of years ago, for example, large regions of Canada and North America were literally covered in lava plains. Fortunately, this only happens every so many few millions of years, and it's certainly not happening at the moment, so we can discount that. And the other one is even more frightening. That's when, on occasion, something like an asteroid or a comet strikes the Earth. And this, of course, has a profound effect on life on Earth, and to such an extent does it affect the climate that invariably you get vast amounts of extinctions taking place. Now, the last really big one that occurred at the end of the age of dinosaurs. In fact, it was what brought the age of the dinosaurs to the end. And something like 70% of all life on Earth perished when that occurred. However, global changes in climate are least of what we should worry about if an asteroid hits. They talked about in North America tsunamis swooping across the United States over a kilometre high. But again, these things only happen 10s, 20s, 30, every 30, 40 million years apart. And at the moment, astronomers are keeping a careful eye on asteroids and some things that are coming close to us, so that if we do find that we're on a collision course with an asteroid or comet, possibly we can do something about it these days. Okay, well, the fact is that these natural phenomena, solar activity, volcanic activity and so on, none of these things are in any way related to the changes that we're seeing at the moment. And I can remember years ago when I was at Victoria University and looking at the results from the core samples from the South Pole. Right? And what these clearly show is a steady rise in CO2 in the atmosphere since the Industrial Revolution. All right? And in fact, when you plot the two, you plot the population on the Earth against this rise in CO2 in the atmosphere, and the two are virtually running side by side. The problem is, you see, the population on this planet has doubled in my lifetime, and we're living on a finite planet. And we cannot go around burning down and cutting down most of the world's forests and thinking that it's not going to have an effect on the environment. The other thing, of course, is digging up and using fossil fuels, where we've got CO2 and other gases, methanes and that, trapped in there for millions of years. We're releasing it by millions of tons per year into the atmosphere just by burning this material. So there is no doubt whatsoever, when you look at the evidence, there's only one thing that's actually responsible for this increase in CO2, which in turn could lead to a runaway greenhouse effect, is us, human beings. Now, this doesn't mean that we don't have to have energy as that. We just got to look at different ways in which we produce energy and so on. We also have to limit the population, because living on a finite planet, we cannot have an infinite number of people being born onto this planet. So it's something we need to look after. And for me, I'm getting on a bit now, but I worry about my grandchildren, what sort of world we're going to be leaving our grandchildren. So we should stop this messing around and talking about global warming change. It's natural, it's something happens. Yes, global climate change does occur, but it is not a natural global change that we're witnessing at the moment. It's definitely something that is observed to happen by human beings. So having said that, we're now going to listen to another little piece of music. And unlike those people on TV who could see Nocturne come up, we've got something entirely different. And what we've got is Boadicea. Okay, folks, you're back with Richard and the night sky. And I thought what I'd talk about at the moment was what we've got coming up at Stonehenge, because there's a lot of things occurring in the Wairarapa at the moment. A lot of work towards making Wairarapa a dark sky site. And if we can do that, an international dark sky, it will be the biggest night sky park in the world. And the reason for that, and for those of you who are watching this on TV, the photograph you can see at the moment is actually just taken from a road near me, from the side of the road, and it's looking at the Milky Way that you can see. And literally 80% of the people around the world cannot see this anymore. All right? So we've got something very, very special here with our night sky. And so which we've been planning for some while, we've got a whole series of astronomical programs which are going to begin to start here. Number one is that we're going to be starting to do regular weekly telescope viewing. This will be a special evening where there's normally on a Saturday it will be a special program about the stars, planets or whatever, and then if it's clear we take you out beneath the stars looking through some of these wonderful telescopes where you can explore the wonders of the universe. Okay, so that's what we call a Stonehenge stargazers. All right, and if you want to know more about it, simply either give us a call at Stonehenge or have a look at our webpage. So that's a regular Saturday evening stargazing that's going to be taking place. In addition to that, for those of you who'd like to learn more about the stars and astronomy, we're beginning some astronomy courses, and one of them is actually starting this Saturday on the 7th. It runs for 2 days. Okay, and so again, call us there. That's all about the introduction to astronomy. And of course, then we have the solstice coming up on the 22nd, which is again on the Sunday. And of course, we're going to be having all the tales of the solstice. So if you want to know who Father Christmas really was, and all those other characters, and why Rudolph had a red nose, you better come along, all right, to the solstice. That's on Sunday, December the 22nd at 7:30 p.m. And with that, I'm going to shut up now, and I'll catch you up in the near future.